every object around you suddenly revealed its deepest secret, the result would be almost impossible to believe. Hidden within even the smallest piece of matter lies an amount of energy so vast that it challenges everything our senses tell us about reality. This is not science fiction, speculation, or theoretical fantasy. It is a measurable fact about the universe, one that remained hidden until a simple equation exposed one of the greatest truths ever discovered. That equation is E equals mc². Millions recognize the symbols, yet very few realize that those 5 characters completely changed how humanity understands matter, energy, stars, and the universe itself. The equation appears simple enough to fit on a scrap of paper, yet hidden within it is a story involving light, space, time, atomic matter, and forces powerful enough to shape entire galaxies. To understand why this equation became legendary, we must travel back to a time before its discovery, when scientists believed they already understood the fundamental nature of reality. For centuries, the physical world appeared straightforward. Matter was matter, energy was energy, and there seemed to be no reason to suspect a deeper connection between them. A stone felt solid and permanent. A flame seemed energetic and temporary. Common sense suggested they belonged to entirely different categories of existence. Yet nature often hides its deepest truths behind familiar appearances, and beneath this seemingly obvious distinction, a remarkable secret was waiting to be uncovered. The first cracks in the old understanding appeared when scientists began studying light with increasing precision and discovered behavior that refused to follow established expectations. Experiment after experiment produced the same puzzling result. No matter how measurements were taken, the speed of light always appeared to remain unchanged. Today, that statement may seem ordinary, but at the time it created a crisis because it contradicted some of the most trusted ideas in classical physics. Researchers struggled to explain the contradiction. The measurements appeared correct, yet the conclusion seemed impossible, leaving physics trapped between evidence and intuition. Then, an unlikely figure entered the story. Not a famous professor or celebrated researcher, but a young patent clerk named Albert Einstein. Einstein approached the problem differently. Instead of relying on larger experiments, he relied on imagination, constructing entire worlds inside his mind and exploring their consequences. One particular question fascinated him. What would happen if someone could travel beside a beam of light and observe it from that impossible perspective? Following that question led Einstein toward a realization that would permanently alter our understanding of space, time, motion, and the structure of reality itself. His theory of special relativity revealed that space and time were not independent stages upon which events occurred, but parts of a single interconnected framework. This idea sounded extraordinary, yet it explained the mystery perfectly. The speed of light remained constant, because reality itself behaved differently than anyone had imagined. But hidden inside the mathematics of relativity was another discovery, one even more surprising than the explanation for the speed of light. The equation suggested that matter and energy were not separate components of the universe. Instead, they appeared to be different manifestations of the same underlying reality. If that conclusion was correct, then every object around us contained hidden energy, not metaphorically, but literally, locked inside matter itself. The relationship could be expressed through a remarkably compact equation whose simplicity concealed consequences extending from atoms to stars. To appreciate its meaning, we must examine each symbol carefully, because every part of the equation contributes to its extraordinary conclusion. The letter E represents energy, the quantity associated with motion, heat, radiation, electricity, and countless other physical processes throughout nature. The letter M represents mass, the property that gives matter substance and contributes to its resistance against changes in motion. The symbol C represents the speed of light in a vacuum, one of the most important constants ever discovered by science. Light travels at nearly 300 million meters every second, fast enough to circle Earth more than 7 times in a single second. The equation then squares that already enormous number, multiplying it by itself and creating a value almost beyond comprehension. That gigantic multiplier explains why even a tiny amount of mass corresponds to an astonishing quantity of energy hidden within ordinary matter. The claim sounds unbelievable, yet the universe provides proof every day. To see it, we must journey into the hearts of stars where matter is transformed into the energy that powers the cosmos. Deep within every star, a remarkable process unfolds continuously, and it is here that the hidden meaning of Einstein's equation becomes impossible to ignore. From Earth, the sun appears calm and steady, yet beneath its surface an enormous engine is operating every second with extraordinary precision and power. At the center of the sun, temperatures reach millions of degrees, while gravity compresses matter with pressures difficult for the human mind to imagine. Under these conditions, hydrogen nuclei move so violently that they occasionally overcome their mutual repulsion and fuse together into helium. At first, this reaction appears deceptively simple because the particles involved still exist after the transformation, merely arranged in a different form. However, careful measurements reveal a subtle but profound difference. The helium weighs slightly less than the hydrogen that created it. That missing mass has not vanished into nothingness. Instead, it has been transformed directly into energy exactly as predicted by E=mc². Every photon of sunlight that reaches Earth began its journey through this process, carrying evidence that matter and energy are deeply connected. The warmth you feel outdoors, the energy absorbed by plants, and the conditions that support life all depend upon this ongoing conversion. Without mass becoming energy inside stars, there would be no sunlight, no ecosystems, and likely no living observers asking questions about the universe. Yet stellar fusion reveals only part of the story, because the true scale of the equation becomes apparent when we examine a surprisingly small amount of matter. Imagine holding a single gram of matter in your hand, an amount weighing roughly the same as a small paperclip or metal pin. If that entire gram could somehow be converted into energy, it would release roughly 90 trillion joules, enough energy to power a large city for an extended period of time. Numbers of this scale are difficult to visualize because human intuition evolved to understand everyday experiences rather than cosmic quantities. This realization raises an obvious question. If ordinary matter contains so much energy, why do everyday objects not release it constantly? The answer is that most matter is extraordinarily stable, and releasing that energy requires very specific physical processes that rarely occur naturally. Scientists eventually learned how to trigger some of these processes through nuclear reactions, allowing a fraction of that stored energy to be released. One of the most important methods is nuclear fission, where heavy atomic nuclei split apart into smaller and more stable fragments. Just as we observed inside stars, the combined mass after the reaction is slightly lower than the mass that existed beforehand. That tiny difference is converted into energy, once again confirming the relationship described by Einstein's remarkable equation. Modern nuclear power stations harness this effect in a controlled manner, producing electricity for millions of homes and businesses. These facilities demonstrate that mass-energy conversion is not merely an elegant theory, but a practical phenomenon that can be measured and utilized. At the same time, history revealed a darker lesson because the same principles can release enormous destructive power when used without restraint. The equation that explains the warmth of sunlight and the operation of power stations also reminds us that knowledge carries responsibility. As scientific instruments became more precise, researchers repeatedly tested the predictions of mass-energy equivalence under many conditions. Again and again, the measurements agreed with theory, showing that tiny differences in mass matched predictable amounts of energy. Over time, E=mc² became one of the most thoroughly verified relationships in the entire history of science. Yet another surprise awaited researchers because they eventually discovered that mass itself is more mysterious than it first appears. Much of the mass we observe arises not only from particles themselves, but also from energy stored within powerful interactions and fields. In a very real sense, matter can be viewed as energy organized into stable structures, a realization that leads to an even more astonishing discovery. Energy can also create matter. The idea that energy can create matter sounds almost impossible, yet modern physics has demonstrated this process repeatedly in some of the most sophisticated experiments ever performed. To investigate the deepest structure of reality, scientists constructed enormous particle accelerators, machines so large that they rank among humanity's greatest engineering achievements. Inside these facilities, particles are accelerated to velocities approaching the speed of light, while carrying tremendous amounts of kinetic energy. When those particles collide head-on, their energy becomes concentrated into an extremely small region of space for a brief instant. Under the right conditions, that concentrated energy can transform into entirely new particles, effectively creating matter where none existed before. These experiments reveal the reverse side of Einstein's equation, showing that energy can become mass, just as mass can become energy. The distinction between matter and energy begins to fade, replaced by a deeper understanding that both emerge from the same underlying reality. This realization becomes even more profound when we turn our attention toward the earliest moments in the history of the universe. Modern cosmology suggests that the universe began in an incredibly hot and dense state where energy dominated everything that existed. Temperatures were so extreme that particles and energy transformed into one another continuously in a rapidly changing cosmic environment. As the universe expanded and cooled, these transformations gradually slowed, allowing stable matter to emerge and persist. The first atoms eventually formed from this process, laying the foundation for every future star, galaxy, planet, and living organism. In a very real sense, every object around us carries a history stretching back nearly 14 billion years into the cosmic past. The atoms within your body are part of that history, linking your existence directly to events that occurred near the beginning of time. Yet the story of matter was only beginning, because the next great chapter unfolded inside the hearts of stars. Within their cores, lighter elements fused into heavier ones, producing many of the ingredients required for planets and eventually life. The calcium in your bones, the oxygen you breathe, and the iron in your blood were forged inside ancient stars long before Earth existed. Those stars shone for millions or billions of years, because tiny amounts of mass continuously became enormous quantities of energy. Without mass-energy conversion, the night sky would be dark. Galaxies would appear very different, and life might never have emerged. The equation therefore explains far more than nuclear reactions. It helps explain why the universe looks the way it does today. Its influence extends into technologies that many people rely upon every day, often without realizing the physics operating behind the scenes. Medical imaging systems, particle detectors, and even technologies connected to satellite navigation depend upon principles involving energy and matter. Researchers continue testing the foundations of physics with extraordinary precision, searching for deeper insights into the nature of reality. Every answer uncovers new questions, and every discovery reveals additional mysteries waiting beyond the edge of current knowledge. That spirit of curiosity allowed Einstein to challenge assumptions that many of his contemporaries considered beyond question. A simple question about light eventually led to discoveries connecting atoms, stars, galaxies, and the history of the cosmos itself. What began as an attempt to understand motion evolved into one of the greatest intellectual journeys in human history. More than a century later, E=mc² remains one of the clearest demonstrations that nature can be both elegant and profoundly powerful. Its message remains transformative. Matter and energy are not separate worlds, but different expressions of the same fundamental reality. The next time you hold an ordinary object in your hand, remember that hidden within it lies the same relationship that powers stars, shapes galaxies, and helps explain the universe itself. That is the enduring legacy of E=mc².